Okay, implicit differentiation. Matt, you guys have your... We're doing 3.5. Sorry, I know it says 3.6, but it's 3.5. The author reordered the book a little bit, and so it's still the same content. And if we go, and on your handouts, I'm not sure what you have, but this page about the orthogonal curves, we are not going to do that, so let's just delete that page. Can do it if you want. We're not going to do this till tomorrow, so I'm going to delete that page. So it's not as many pages as we're not doing that either. 2 pages, okay. There we go. Boom. Okay. When you are talking about defining a function explicitly versus implicitly, we did this last year, and we need to make sure that we understand. Explicit means that you actually have y equal to some function of x. When you solve differential equations, if it's possible, you need to explicitly solve for y to get your full points on the exam. And that has been on every exam that I can think of solving differential equations. And on the BC exam, it was what we call the double bubble. 4 points are BC topics, and the other 5 on the 9 points are AB topics. And it's almost always been a differential equation. It's one I've been grading. You only get 1 point for finally finding what y is out of 6. So is it that big a deal if you can get 8 out of 9? No. So it's nice to be able to do that, but it's not the biggest place you're going to get points. It's going to be moving along through the problem. But we explicitly solve for y, so y equals x squared. If it's implicit, it might be like x times y is equal to 1. I know I can solve for y, but I don't know what it is unless I do some work to find out what it is. That's the only thing that's different. Sometimes I don't want to solve for y because it's actually easier to do the problem implicitly than explicitly. Okay. And that's exactly what I'm saying there. So let's go through and do some problems. Example 1, here's the equation of a circle. If you solve for y, it's not so easy. If you solve for y, it's x squared plus y squared equals 9, then what do you have to do? Minus x squared. And then you have to solve for y. So that you have to square root both sides, and this is not y, but the absolute value of y, which is why you get 2 answers to this. So y is equal to the square root of 9 minus x squared. That's the top half of your circle, and y equals minus the square root of 9 minus x squared. That's the bottom half of your circle. So if I want to find a derivative of that, it's much easier to actually do it as written. Is this a function? The circle, right? Is this a function? There's the top half. There's the bottom half. Does that pass the vertical line test? No. So, no, it's not a function. So we do actually do this? Okay, yeah, I thought there'd be a space for it. Okay, so this is the implicit version. We recognize that as a circle, and actually the explicit one you don't usually recognize as a circle. Because if this were on the exam and you wanted to find the area under that curve, you would do it using geometry, because it's a circle. So that's pretty easy. But it'll be written maybe this way. Okay, so you understand the difference between implicit, where you do not solve for y, it's just y is embedded in the problem, and then the explicit. And when you take the derivative, that's when you get that differential equation with all those x's and y's in it. Remember when you solved differential equations and they had x's and y's in it? It came from implicit differentiation. Okay, what about that one? Is that implicit or explicit? If implicit, can you solve for y? No. It's not even possible because you have a polynomial mixed up with a trig function and then a product of those. I can't even do it. Pardon? It is a mess. You can't do it. So you actually have to take the derivative implicitly. So put a no there. It's not impossible. It's not like I can't do it. It's just not possible to do it. Okay, so that's the advantage, and then when we do our inverse trig, we'll see that. So let's go ahead and do these two problems. Oh, they're not mixed together, but they are. So let me help you with one of them, and doing the second derivative is even tougher. Let's do this one. Now, when we do derivatives, the operator is d dx. I want to see how something will change if I change the x's. In this case, it's a y. Had it been a z, I would have a dz dx in there. So I'm going to take the derivative with respect to x. Notice it's not dy dx. It's just d dx. It's like a plus sign or square root sign. It's just saying, let's find the derivative of that. Let's find the derivative of this one. And let's find the derivative of this one. And the right side's the easy one, right? Okay, what's the derivative of x squared with respect to x? It's 2x. Then you really do use the chain rule. Then you take the derivative of the inside function. You always do that, the derivative of x with respect to x. But you don't write it down because that's just what? 1. Plus, and then the derivative of y squared, but with respect to x. Well, first I do the derivative of y squared with respect to what's in there. So it's 2y. And then you chain it, multiply by the derivative of the inside function. Now put parentheses there so you see it's a derivative operator. That's where we have the problems, understanding what a derivative is. You always have to talk about how if something changes, as something else changes. And it's a composite function. So I have to use the chain rule. And what's the derivative of 9? 0. Okay, I don't require that you write the dx over dx. I don't care. I'm doing it more just to show you that that's really what's happening. And so this ends up being 2x. That's 1. I don't have to write the 1 either. Plus 2y. And then that's dy dx. We say dy dx. This is a short way of saying the derivative of y with respect to x. And we all do it. Otherwise, I would just not do it. And then you solve for dy dx. So what do you do to solve for dy dx? No? Subtract 2x. No, that's a good guess, actually. So 2y dy dx equals negative 2x. And actually, you weren't wrong. You could have factored out 2 and just gotten rid of it. And then divide by 2y. And that's why you get x's and y's in there. So what we're doing later is, I'm going to give you this, which is a differential equation. You're going to separate the variables and come up with the equation of the circle. But that's later in the year, but you should see how they're tied together. I could solve for y. Oh, I did solve for y. Remember what y was? Y was equal to plus or minus the square root of 9 minus x squared. But this gives me both derivatives. Do I have to put the y back in here? No. Do you want to do the derivative of this one? Let's do it. And let's just do the positive one. Okay. So if y is equal to 9 minus x squared, I got to write this as a 1/2 power because I can't use the power rule otherwise, right? Okay, David, what's the derivative of this thing? Ooh. dy dx is what? 1/2 9 minus x squared to the negative 1/2 times minus 2x. Okay, but you guys, honestly, look at this and look at this. Which was kind of easier to look at? This is more pleasing to me. I'd rather see the x than the y there. It's just simpler looking. Is it the same thing? Well, let's find out. Well, we can simplify it. What happens to 2? And I'm still left with a negative sign. And I have an x here, and let's put that in the denominator because that's what a negative exponent means. The square root of 9 minus x squared. Yeah, it's the same thing. But this took more work algebraically to deal with than that. That was easier. Now, I certainly can do this explicitly. But what about this other one? Which I'll recopy. Maybe somebody wants to come up and do this one. That one, x cubed. Actually, I'm going to put it on another page. X cubed. I ran out, but I'm going to have to go get some. It was Halloween. What's the other side? XY. Ooh. It's what? Oh, that's good. Sine XY is a lot harder. You want me to do this, or is somebody going to come up and do it? Come on up. Yeah, you can try it first. He's already ahead of me, which is good. And the product rule here is the tricky part. Yeah. There you go. And there are times when I need to be able to do something implicitly. And this has been, not every year, but it's been on the exam often. And what they do on the exam is they give you the answer. They say, show that the derivative is this, because there's going to be more parts to it, and they don't want you to be working with the wrong derivative. It would drive us readers nuts if we had to go through and, because we have follow-through errors. So if you get the wrong derivative, then we have to follow through all the rest of your work to see if it was right. And there are times when I have to do that. Does everybody get that answer? Girls, did you get that answer? Okay. Oh, that's what this section's about. I don't believe there's much. Oh, there's a little more. Should be. Here's what I'm going to do. I have. Well, I don't know if you have.
I have. Really good at this.
Okay. Well, I'm going to paste it right here. Edit, and we're going to paste it. And I want to write the equation of the tangent line at 0, 0. Now, you do sometimes have to check to make sure that 0, 0 is on the curve. Sometimes they trick you, but most of the time, 0, 0 is on the curve. Ones I make up might not be. And I want the equation of the tangent line. So it's y minus 0 equals my slope, and then it's x minus 0. What has to be true about your slope? It might be 0, but what has to be true about the number you put there? It has to be a number. It can't be a letter. Okay, so I don't know if I put in 0 in there. Well, that's 0 minus 0. This is kind of a boring one. What's the cosine of 0? Good. So it's 0 over 1, and you're right. 0. By one I made up. So that's what this section's about. There's some talk about orthogonal trajectories. You do not have to notes on the exam, but you will maybe run into this in physics, have you?
Wait, what's that called?
Orthogonal trajectories just means that two curves, if you were to draw their tangent lines where they intersect. Whoops, I didn't do that in the right place. And you draw your tangent line over here, these tangent lines would be perpendicular. So it's not a big deal, you don't have to know that, but orthogonal will be perpendicular. If if the two curves are orthogonal trajectories, their slopes will be perpendicular. I think that's it. Okay. We're doing inverse trig tomorrow. And I know there's a ton of stuff going on, like if you're in the play,